Welcome to today's webinar on how to manage software development without being a developer. Our presenter is Michael Linzer, who is the founder and CEO of Reinteractive, a software development company specializing in the Ruby on Rails application development framework. With hundreds of successfully delivered projects for clients and a passion for intelligently solving software and business problems, Michael has a wealth of experience to share. Hello, Michael.
Thank you very much, everyone, for coming along. I really appreciate you being here. So this presentation is about how to manage software development if you're not a software developer, but really it's how to manage software development for just anyone. How do you actually get around the problem of coordinating developers and time and resources and getting a project to be a success? Now, I've been doing software development now for the better part of 2.5 decades, something like that. And in that entire time, I've spent a lot of money learning these lessons in a very, very expensive way. And I think anyone who's managed a software project will commiserate with me. And it's strange because it seems like we've been doing software development now for, 50 or 60 years. So why is it still so hard? Why is it so hard to predict the outcome of a software project? Why is it that even if you get the best developers and you've got a project manager who's done a successful project previously, you can start on a project and the whole thing just spirals out of control? And you end up throwing more developers, more time, spending more money, all sorts of stuff. How is it that we can have our governments building websites that are basically a database about schools' performance and spending tens of millions of dollars in putting it together? Why? Why is all this happening? And I've been doing development for a long time. I've written software that I think has been downloaded about 65 million times now. That's open source software. I just wish I got paid about 1 cent each. That would have been nice. But anyway, it's all good. And, even with all of that, that software project's still going. It's been going now for 10 years and it's still chewing up resources. And it's amazing. It really is amazing. So hopefully in this presentation, I'll explain some of the concepts that I use to try and manage software projects and give you plenty of examples as we move through. So feel free to ask questions. I am very good at controlling time, so I'll make sure that the questions get answered in the same period and we'll get through it. This is also being recorded and it will be up on our website afterwards for you to give to other people in your team or share or do whatever you like. So who am I? Well, I briefly just went over it, but my name is Michael Linzer. I'm the CEO and founder of Reinteractive, which is a software development firm based in Sydney, but is actually worldwide. We have better part of 43 staff or something between Australia, New Zealand, the America, like USA. I think we have 1 in Portugal and 2 in the Philippines now. But they're all full-time staff and they all work for me. And we build custom software development built primarily in a product called Ruby on Rails. And we also do a lot of Salesforce integration work with our Salesforce e-commerce solution called Store Connect, which is going gangbusters at the moment. So that's who I am. I'm a software developer as well. I still do software development, even though I'm running a couple of companies, and I love it. And that's who I am. So really the question is, why are software projects so hard to get done on budget? And this is a key problem for so many people out there. Software development in many cases just seems like black magic in terms of trying to estimate and predict. The key reason for that is more often than not, the software being developed is unique and it's never been done before. And it's usually the reason why you're doing the software development in the first place. i.e., if that software that you were developing already existed, if you'd already spent the money building it, it was sitting on the shelf and it did exactly what you wanted, well, you wouldn't spend any money on software development because you'd just buy the pre-developed piece of software. And this is the fundamental reason why software projects are hard to estimate. Because when you're developing something that's brand new, that's never been done before, you don't know what you don't know. And until you find out what that thing is as you're going through the project, you're never going to know. And it doesn't matter how closely you look at it or scope it or whatever, you still don't know what you don't know. And there's a fundamental thought process around software development that I think there is a mistake in the industry thinking this way. It's quite often thought of that software developers are a lot like tradesmen or builders, where what they do is they take a plan and they lay bricks, or they put up walls, or they pour some concrete, or they render the wall, or they affix the roof, or install the windows, and then paint it at the end, and bang, it looks great. I think that's a misconception about what a software developer is. In software development, the thing that puts the bricks up and puts the walls together and does all that is actually the computer. It's the one that takes the overall plan, which was created by the software developer, and turns it into a running piece of software. And if you want that to happen faster, you throw more computer at it, and it can go faster. The software developer, if we're using the same building analogy, is actually more like the architect. And it's the architect and the planner and the town planner and all of those people that generally have much more of a flexible cost when you go to develop a house. You might go to an architect and say, hey, I want a house. And he goes, yeah, sure. And you go, how much? And your answer would be, what do you mean, how much? You haven't told me what you want in the house. And you're like, well, I want a house. I want walls, I want windows, I want a kitchen, I want a toilet. There better be a door, and I want a lock on the door because I only want permitted access. And oh yeah, I need a bed. And the architect goes, well, I don't actually do beds, but I can make space for a bed. And it's like, well, what do you mean you don't do beds? So the architect is trying to eke from you the design. And commonly the questions that the architect's going to ask you are things like, well, what sort of fixtures do you want? Do you want this thing to be a 10-story house? Do you want it a 1-story house? Do you want 15 bedrooms? Do you want 1 bedroom? Do you want gold plating on the doors and walls and windows? What sort of house do you actually want? And this is where the trouble comes in, because the software developers there trying to eke this information out of you. Now, you might first, instead of going straight to the architect, you might first go to a concept architect or a sub part of that company, which might just put together some concept sketches for you of generally, this is what I want to build. And then that would be like the UX developer or the wireframe and prototype person coming up with some broad ideas. But what the software developer is doing is actually creating those architectural plans, bit by bit, going back and forth with the customer, working out, well, this plan and this room, well, that room's not quite going to fit there. We're going to have to move it over here. Oh, well, we've already put it in there. So if we're going to move it over there, we're going to have to redo all of these other bits to make it connect properly. We're going to have to move this door and all that sort of stuff. Once the plan's written, getting it built is a no-brainer. And in fact, if you take plans to pretty much any builder, they'll go, oh yeah, that's going to cost about blah. Because they've got the plans. They've got all the plans. They know that this door will fit in that spot because it says so on the plan. It's drawn there and we can see it. So they can estimate with quite good accuracy. The only time you're really going to get hit with additional costs in building is if the site has some unknown problem, or the builder goes out of business, or there's a legal problem or some planning problem. But it's the architect that's going through all the steps of figuring out how do we build this thing. And that is the software developer. And if you take that viewpoint when you're building a software project, that the developers aren't doing the building, that's the computer. What the developers are doing are creating the plan of the project. How does this all hang together? What all sort of fits? That instantly changes your viewpoint of the development team and what they need, because it starts getting you into a frame set of, well, I better keep that communication as high as possible. And it also gets you into the frame set of, I need to start removing as many unknowns as possible. This is also why if you buy a house, if you buy one off the plan, like a Masterton Homes thing or something that's got a preset design, that's why it's so much cheaper, because you're not paying for any software development up front. Same if you're just buying a plugin on a WordPress site. The development cost is very, very minimal. And that's why, because you're not paying for any of that architectural design at the front, which is what the software developers actually do. So this is a primary problem. the other aspect of this, and this, when I first learnt about this, and it's not my original thought, unfortunately. I wish it was. I can get a link to the video at a conference that happened about 8 years ago where someone talks about this, which is really, really good. If anyone wants that, let us know and we'll send it out. In fact, when this video goes live, I'll add it as a link on the previous page. But there are axioms of software development that remain unknown. And this is something that I learned after getting that first realization that the software developers aren't the builders, that they're the architects. I started to figure out what these axioms are. And axioms mean a sort of a self-evident truth, right? They're laws that you can't really break if you want to be sane and survive in this development environment. So let's go through some of them. There's a bunch of them that I cover in my upcoming book called Confident Software, but the axioms of software development is what I'll be covering here. So the first axiom is that desired features will always exceed available budget. This is almost a truism, and anyone that's done software development knows this to be true. It does not matter what your budget is. It doesn't. Yet the features you want will always exceed your budget. And that budget could be time or money, right? And if anyone here doesn't believe that's true, then go have a look at what the line item expense for software development is at Facebook or LinkedIn or Uber or anyone like that. Stripe payments. It doesn't matter how big you go, even Amazon. It doesn't matter how many features you develop. You will always have more features than are available in your budget. And this is a really critical thing to understand, because if you don't get this, then what's going to happen is you're going to be always implementing the wrong thing. So the first thing you need to do is take this to be true and go, okay, well, what that means is, in reality, is I am not going to get every feature I want in this application because it's impossible. The reason this is impossible, if you want an understanding of this, is that software attempts to mirror the real world in some manner, right? So an online store is the attempt of mirroring a physical store. And if you built a physical store, you'd actually never be done, right? You're always rearranging things. You're always repainting that wall. You're putting a new feature sign up. You're adding new marketing. You're changing the bikes. You're changing the stuff. It's a constant change. The only things that stay the same in this world are things that are dying. If you are not constantly improving, then you are dying. Like there isn't two options there. There isn't a third option there. You're either getting better bit by bit every day, or you're getting worse. There is no such thing as staying the same, because if you're staying the same, the world around you is getting better. The world around you is improving. So then by definition, you're going backwards, right? Just improving gradually over time is really what staying the same means. So your software is always going to be in this state. And, I sell software development to clients. I also have 3 or 4 software as a service applications that I maintain with my staff and run. And I have full-time developers on those all the time. I spend lots and lots of money on those, and they just keep finding more features, and our users keep finding more features and all that sort of stuff. So how do we use this? How do we use this to get the software project on track? The key thing to use is making a list of what are the critical features. What are the features that we absolutely have to get done minimally for this project to be a success? And I'm not necessarily talking about a minimum viable product here. That would be part of it, and you would do that first. And a minimum viable product for many software projects is actually a sketch on a piece of paper that you can show to someone and say, hey, if I built this, would you buy it? That could be a minimum viable product. It doesn't actually need software. It could be a sign-up form. That could be a minimum viable product. What I'm talking about is what is the features that we need to develop and deliver in order for this project to be a success, counted in whichever way you want. And success could be getting more signups. Success could be the project's running and running the business now. It could be whatever. But you need to be very critical on that critical feature list. You need to really evaluate that feature and go, okay, so there's this feature here, which is if I click on a line item, it should pop up a window to allow me to edit it. That line item. Okay. So that's a feature. I should be able to edit the line item, but do I really need it to pop up? Yes or no? Well, no. I don't have to have it pop up. That's a nice thing and it will look good, but is it actually a critical feature? No, it's not. Well, okay, maybe it's just easier if when we click it, the page changes and I just edit that form and then I save it and I go back. Yeah, but that's not such good design, you know? It doesn't feel like LinkedIn or Facebook, the client says. And you go, well, yeah, that's right. That's because LinkedIn and Facebook spend $1 or $2 million a month in software development. So what we're going to do is we're going to get this click, edit, go to the page, fix it, go back thing working. That's going to be running and that's going to allow you to launch. And then if there's more money and more time at the end of the project that we have time for, we will turn that into a pop-up form. That's not a problem. One does not stop the other, and we can very easily turn that into a pop-up form once we've got all the other features developed. So that's an example. Now, you might say, well, that's a bit overkill, you know, doing the pop-up form, that's only 3 hours or 4 hours. Yeah, I know, but you do that 20 times and there's 3 or 4 weeks. And that's the sort of thing that will derail a project in terms of getting estimates done, because the developer will look at it from a broad sort of overarching point of view of every other project they've done and come up with some guesses on how long it's going to take to implement certain features. And they might see, be able to edit line item. And they go, oh yeah, I could just make another page that could go there, click it, go there, go back. Yeah, it's half a day work. And then it turns out to be, it needs to be a modal. So it needs to be a pop-up form on the page. Well, okay, what if the form is too long? Okay, so now we need to have a pop-up form that scrolls. Okay, what if it's too wide? Okay, well then it needs to be different widths. What if I'm viewing it on a mobile? Okay, now I need to make the modal form, pop-up form, mobile responsive. So I better fix that in. Oh, but what if they're on IE, not Chrome, which doesn't necessarily support grids at this time? Oh, well, that means I'm not going to be able to use that standard CSS stuff. I'm going to have to put this CSS shim in. And suddenly the modal pop-up form is now a 2-day project. And that went from 3 hours. So these are the sort of things that you will have as a problem. And it's the most important aspect of your job as a project manager is to whittle down that critical features list to be as bare bones and as simple as possible. You can always add features later. There's no limit to when you can add more features, but you've got to get the thing launched. You've got to get it live. You've got to get it earning resources for you and the organization. So this is the number one thing we go over with our clients when we start a project. And it's the number one thing we look out for. There's a triangle on this, which is features, budget, and quality. And really pick any two. And that's how you can describe it to a client. And that's how, you know, you can show some of these interrelationships. The more money you have, the more of all three of those you can have. But if you reduce budget, it's going to also reduce features and or reduce quality. So these three items are very closely related in every software build there is. But yes, features will always exceed available budget. Seems simple, but it's true. Now, because features always exceed available budget, the next most important axiom is that communication is king. And too often I see software projects sort of sending the developer off into the blue yonder to go and build something, and she comes back 2 weeks later with a solution and the client goes, oh, that's not what I wanted. So you've got to keep the communication very, very high. That means lots of deployments, lots of demonstrations, lots of updates in chat rooms or screenshots or whatever. Communication is the most important thing outside of the client expecting all the features for no money that will derail a project. If communication goes out, the client of the project starts to feel ignored. They don't have any reality of what's going on anymore. And because they don't have any reality of what's going on anymore, their love of the project, their affinity for the project will start to drop. They'll start inventing things that are happening, and in a month or two, the whole thing blows up in your face. We have rules in Reinteractive where our developers need to be updating the client at least 2 or 3 times a day on what they're doing and where they're going with the project. And that keeps that client engaged and keeps them up to date. We put all of the work we're working on within Stories, within our task tracking system, to make sure that the client sees what's happening and that they're constantly updating their, accepting the various stories. In fact, one of the side effects of this was I was trying to work out what the key performance indicator or statistic of a software developer was. And I spent quite some time working this out. And initially, you go out to the market and say, well, what's the key performance indicator of a software developer? And people will come back with different things like hours delivered or lines of code written or whatever, right? None of that really worked for me, because if it's lines of code written, well, the easiest way to become better is just hit return more often on your keyboard and make the line shorter. So that's obviously not the right thing. Hours spent coding, well, that's obviously not the right thing, because then the way you get better is get worse at coding, so it takes you longer. So that can't be it. So the one I settled on was actually features delivered, and with no regard to how big the feature is. So it's just the number of times a software developer delivers an item of work that is then accepted as done by the client of that project. Now, this creates a very interesting game metric between the client and the developer. The developer will want that statistic to go up as high as possible. So therefore, they will make each feature as small as possible. So create a sign-up form will be broken into 10 different stories or 10 different sub-features. That's totally fine, because what that then does is it forces the developer and client to have a much higher rate of communication. The client now has 8 different items to accept on the various different aspects of that sign-up form, and it gives that client more opportunity to go, oh, we forgot number 9, as opposed to just click, yeah, the sign-up form looks like it sort of works, so I'm fine, I'll hit accept. So it actually drives up the communication level between the client and the developer, which is something you very much want. So yeah, number of features delivered and accepted as done by the customer of the project without regard to size of the feature. So what I mean by without regard, you might have, implement the dashboard and you say, well, that's actually a 20-point feature. Don't do that. Don't do that. Don't make that worth 20 more points than the sign-up form. Just make every feature worth 1 point on their KPI. And if you do it that way, the developer will drive the size of the feature down because they want more points, and it will drive the communication up with a client. And I'm a software developer. I can tell you the number one thing software developers don't like doing is talking to other people, because other people are strange and they do things that don't make sense, and they're not like computers that do what you tell them to do. So you want to encourage that communication as much as possible. The next one is always consider the return. This is a point on when you've got this features is exceeding budget and things like that. This is a key one in working out, well, which feature should I develop? And this allows you to go, well, okay, if the customer can edit that line item, that's a return. How much better is the application if it comes up in a pop-up form? 5% better, 1% better, 0.1% better? Okay, say it's 0.1% better. Is that worth spending 3 days building it? No, not right now. Good, let's move on. Let's pick the next thing. So this is where you need to consider the return of every feature that you want to develop. Seems pretty obvious, but doesn't happen very often. The next axiom, design, validate, build. So this is the whole concept behind when you are building software, you want to get the application in front of someone as soon as possible. So creating a quick mock-up of what you want to build first, showing it to the end user, making sure that that's where you want to go is a key process of what you need to do in order to make that feature a success. The earlier that you can get something in front of the end customer as a end goal of what you're trying to build, the more likely you are going to be in succeeding on that project. because the customer will be able to give you feedback much earlier in the piece. And that feedback can then change very quickly at the design stage. If you're only getting feedback at the build end, you're going to be spending a lot more money, because to change anything, first the developer has to undo what they've done before they can do what you want. Another key axiom is be ready to go live. And what I mean by this is obviously in the first week, maybe this might not be possible, but 2 weeks in or 3 weeks in on a software project, it should be definitely possible. The application should be able to go live at pretty much any moment. It should be feature rich enough. And this goes right back to that first, axiom of features exceed budget. This is why you need to complete those critical features first. So the goal of any software project should be, how fast can we get this thing live? Even if it doesn't have enough features to really make it worthwhile, we should have enough features to enable the basic use case as soon as possible. And you want that as fast as you can, because the truth is budget could run out at any point, and you don't want to be left with an application that doesn't do anything because there's too many sort of half-done things and nothing really talks to anything. You're much better off focusing on a key aspect of a build than trying to do everything at once. We're actually doing a project right now where we're replacing 7 different websites for a major international organization, a name brand. I can talk about it in a few months, I'm sure. And we're replacing all of their applications with one Store Connect application for e-commerce. And that's a huge project. But the first thing we're launching is the ability for them to have their corporate website running on the Store Connect application and be able to browse the products. Not purchase the products, mind you, just browse. And we've reduced that down to as small as possible so we can get that launched within 8 weeks. And that lets us get that in front of the customer. It starts surfacing up various issues and problems that we need to be able to do the rest of the project. And it forces things to get done in a much more efficient manner. So being ready to go live at any time is very important. Ownership and accountability. This is another key aspect, is that you really need to make sure that the person that writes the code is the person that gets the code into production, and it's the person that debugs the code, especially during development. You don't want one person to write the code, throw it over the fence to some operations team who then get it live, and then they report back bugs, and then eventually the first developer gets it and blah, blah, blah. You want that software developer to own that code all the way into production and live. This is just a huge increase in efficiency. You're not having to describe things and go back and forth with other people. You're just getting that one developer all the way through to done and getting that feature all the way through the line. And it also is a great benefit to the developer. They feel a lot more trusted. They feel more empowered to fix things. They'll originate more if they see something that's not right. And it just treats everyone in a better state. The next one is stability over features. This comes back again to that first axiom, which really is the overriding one, that desired features will always exceed available budget. What you want is you want an application that does what it does well, not an application that does 20 things in a really buggy way. Because nothing will turn off your prospective end users more than an application that can't even do what it says it can do. So you really want to identify what are the key aspects of this app that absolutely need to work. And then we're going to focus on those. And really that just comes into the desired features exceed budget idea and getting those critical products or critical items out first. But it also comes into play when you launch. You need to build in some time to go and do some bug fixing, because it doesn't matter how well you develop, you'll always find bugs in any software application. It's just, bugs are actually unimplemented features in many cases. Like, how could I give you an example? Well, say you're recording a value every week and you record that value once a week, and the application takes that value and it records that value. Well, then on a weekly basis, you could look at a graph and that would look quite correct. Every week it's going up and down and up and down, and that looks fine. But then you go, oh, okay, I just want to view this monthly. And you turn it into a monthly view, and now suddenly every second month, it seems like there's 5 times the weekly value, not 4 times the weekly value. And you go, well, that doesn't look right. In April, we actually did less, but the value is higher. And the developer goes, that's because we're only recording the value every week. And in April, there's 5 Fridays, and in February, there's only 4 Fridays. And the Friday that's in April is actually just the last day of the Friday. It's only the last day of the week. So the entire week of that, all the values of that week are being counted in April without 4 of them being counted or 6 of them being counted in February. And you're like, well, that's a bug. We should fix that. How could that be that way? That's stupid. Well, actually, no, it's just an unimplemented feature. And the unimplemented feature is when you're entering a weekly value, if that week goes over a month period, the system needs to be smart enough to recognize that and then prompt the user, hey, do you want to split this value over 2 months? So this is where you've got to look at bugs and features in sort of a new light. Sometimes, don't get me wrong, sometimes there are bugs, right? The system's just doing the wrong thing. But usually it's because the feature has not been developed enough to handle the edge cases of the real world. Software, as I mentioned before, is an attempt to replicate the real world. And the real world is not black and white. There are lots of gray areas in the real world. So software has to have ways to handle that. A computer can't just intelligently figure it out. We actually also wrote a blog post called Are Bugs Considered Features, I think. And we'll get that link sent out to everyone on the webinar. We'll put that link on the video as well. So yeah, you've got to prefer stability over features as much as possible. There is also a case to be said on we've got to get something running so that we can get some traction and that sort of thing. That's fine. But just be aware that if you do a push rapidly to get some features out, you're going to have to come back and pay down that stability debt or that technical debt on the project to clean that up and make it more stable and do things like that. On my own software as a service projects, quite often I'll tell the developers, I need you just to spend 3 days, just go and fix whatever you want to fix. Go to the bug tracker and just close some bugs, do some refactoring, just go for it. I basically give them their head, which is a riding term. You let the reins loose so the horse goes wherever it wants. And I just let them go and do some bug fixing so that they can handle that stability as well. Because every bug to a developer is also a stability issue and something that they don't like. Another one is stick to your knitting. So this is where if you're building a platform that's an e-commerce solution, don't try and go and build a payment provider. Unless you're doing so many billions of dollars a year in financial cost in transactions that it makes sense for you to go build your own Visa payment gateway or something. Just build what it is you need to go live. Again, we're talking about features over budget here. You just got to build what it is you need. Outsource as much else as you can to other proven software projects. If you need to upload files in the system, use Amazon S3 or some Google Cloud Storage or whatever. Don't try and build a whole file hosting service. I mean, they're obvious examples, but there's a lot of these sorts of examples that happen. If you need marketing automation on your application, plug your application into Salesforce and use Marketing Cloud, or use MailChimp funnels, or use ActiveCampaign or whatever. Hook into those sorts of things and get them to run that marketing funnel. Don't try and build all of that stuff from scratch, because those other companies, they've spent millions of dollars quite often building that, and you don't have millions of dollars to build that. It's part of your software project. It's not the whole thing. So stick to what's important to you. Test adequately. This is a fun one. Software, as I said, has bugs. But when you're writing software, one of the key things to do is write another piece of software which tests that first piece of software works. And the reason you do this is it gives the developers confidence in adding future features. So say we've written a piece of software that goes, before the user can sign up to this service, check that their height is more than 6 foot, right? For whatever reason. Well, maybe later you implement a change to the system which allows people under 6 foot tall to join your application. And the developer goes and implements that. And that developer wasn't around when you implemented that first feature about the 6 foot high requirement. So that developer just goes, oh, don't see why that would be a problem. I'll just go ahead and implement it. When they implement it, if there was a test written around that first requirement, the system will give that developer an error saying, warning, this new requirement violates a previous requirement. And at that point, the developer can either go, yeah, I know why that is, good, I'll go and fix it. Or they can come back to you as a stakeholder and say, hey, hang on a sec, there was a requirement here about people being over 6 foot tall. And now we're going under 6 foot tall. Is the old requirement no longer valid, or is that old requirement now only valid if another condition exists? And then you as a software stakeholder will be able to go, oh, no. The 6 foot tall thing is only if they want to be part of our basketball team. So just do an additional check on the 6 foot tall thing to see if it's also if they're signing up to basketball. And the developer goes, oh yeah, easy, done. And then it's fixed. If you didn't have tests, what would happen is that change would go into production. No one would know that the 6 foot tall requirement for basketballers has now been broken, and you would have a tiny basketball team. So what you want to do when you're testing, though, is you want to test adequately. You want to test for what we call the happy path, which is if everything's sort of going right, this is what the software system should do. You don't want to test every individual line item of the code. That would be ridiculous. No one's got the money for that. But you do want to put in some, good functional full stack tests that are testing the applications running correctly, or perhaps testing all the outputs of a certain algorithm to be the exact right way that you would think. Given these inputs, it should say X. Given those inputs, it should say Y. Given those inputs, it should say Z. If you could build that up as a software stack with tests, then it means if you make changes to that algorithm in the future, you can see which things are broken and you can tweak it and modify it. The next one is that automation builds productivity. What I mean by this is that when you're deploying software and writing software, you want to automate as many things as possible. So your build process should be automated. Your deployment process into production should be automated. Your ability to deploy software into staging should be automated. What do I mean by automated? Well, what I mean is that to deploy your production environment on an application that's going to have continual work, you don't want someone manually to be copying files onto a server or running a 10-step manual process. You want to automate that as much as you can. And the reason you want to automate it is it makes deployments easier, and it makes the ability to roll something back if you push an error into production possible. And this is really important because the developer might develop a feature. It makes total sense. You approved it because you saw it in staging environment and it looks good and it's all fine. So you all go to deploy it. And just before you deploy it, the automated test process has come back and said, actually, we just found an error on the 6 foot tall requirement on basketballers. And that stops the deployment process. You go, we're very lucky that automation process caught that error before it went live. Good, let's fix it. Boom, now get it live. But the other thing is you might push through a feature all the way to production and everyone's happy with it. And then one subset of your users goes, this is just completely breaking the system. We can't use it anymore. Well, if you have your automation in place, you can just roll that back and put the old version back live, and then it's not a problem. I had this exact issue being a software developer who also is the project manager on my own software projects is a very dangerous thing sometimes, because I get to develop what's called founder code, which is subpar code that I think is good enough, and I just get live. And I don't do it as much these days, but I used to. And one day I did an update, and believe it or not, what I was updating was that the copyright footer should show the current year on the copyright page. Now that's pretty obvious. But of course I was being smart. I didn't just want it to show like hard code in 2018. At the time, I wanted it to automatically update next year to 2019 and 2020 so that I wouldn't have to go in and fix it every year because I didn't want to. So I made it automatically determine the date and display it. Now, this is trivial. It's a very easy fix. It was literally 3 minutes of work, and then I pushed it live. And at that point, I went out to go and meet my now wife for dinner. I forgot to take my mobile phone. So I left to go and see my wife, and I'm having a wonderful dinner on a Friday evening at 7 p.m. And I get home and pick up my phone, and there's like 10 SMSs from different clients that are complaining about the application. My email inbox has been flooded, all sorts of things. And what had happened was that I had pushed a syntax error into production that only came up in a certain way, and it was causing the application to crash. Luckily, our entire process was automated, and I used our OpsCare service. And when our OpsCare team saw that I'd pushed something into production, and then after that, the whole site went down, they first tried to contact me, and then when they couldn't contact me, they just pressed a button and the whole thing rolled back to the previous version and the whole system came back up again. So total downtime was perhaps 10 minutes instead of being 3 or 4 hours, which is how far I was away. So this is where automation builds a lot of productivity. It also means developers aren't as afraid to push new features into production because they know that the system will help them make sure it's live. The next one is the idea that maintenance is cheap. And this is actually the last axiom of software development, confident software. So what do I mean by maintenance is cheap? Well, if you build a project and you get it live, and then you do no maintenance or development work on it for a year or two, when you come back to work on that project, it's a couple of years behind the current trend in software development. And that means that you're going to spend weeks and weeks getting it up to date. It is much cheaper in the long term to chip away at that on a weekly basis with some sort of maintenance agreement or support contract or retainer or whatever you want to get with your development agency to keep that application up to date in terms of security and current features and requirements. You know, if you've even got a website that's a WordPress blog and you've got all these plugins in it, and that WordPress site is important to your business, it would behoove you to spend however much it is per month to just keep a company on board that is constantly updating all of those gems and the WordPress versions to the latest versions to save you from security issues. We had a client that had a site that they didn't maintain, and they now do with us. And they they don't do it with us. They do it with someone else who I think is actually on this call. But they had a plugin which someone logged in and attacked their site and replaced that plugin, and it sent out an email to every one of their contacts with links to various pornography sites. That was really expensive in terms of reputation, brand management, and all that sort of stuff. And factually, it wouldn't have happened if they had a maintenance plan in place, constantly updating that application to the latest versions. So maintenance in the long term is cheaper than leaving it for 2 or 3 years and coming back. I mean, just imagine if you didn't clean your house for 2 years and then you walked back in after living in it for 2 years. How hard would it be to scrub those floors and clean up all that grime? How much easier is it just to keep it clean every week? It is. It's much, much easier. So this also applies to software. So that's the last axiom. I don't know if there's any questions, but feel free to ask them. We are getting this Confident Software book out this year. It's a labor of love. Anyone that's ever written a book knows how hard this is, but I am going to get it done. So that will be released. You'll all get links to a copy when that comes live. One other aspect of what I want to say is that Ruby on Rails solves a lot of these problems, usually, as long as you implement it. And that's why we chose Ruby on Rails as our software development platform. It has a lot of things that allow you to stick to your knitting. It allows you to develop out MVPs. It allows you to have lots of communication, testing, all that sort of stuff. And it's built to handle these sorts of large, complex requirements. It's got a very mature history and an ongoing following, and that's why we use it. And I'm not going to go into too much about that. We do have an offer in Webinar Jam that will let you download a free copy of our Why Ruby on Rails book. So that will take you to a website that gives you a link that allows you to download it. The Rails community also is very large. Almost 4,000 different developers have contributed to the framework. 150,000 plus software libraries that we can plug in, and 177 million downloads. So it's definitely been used quite a lot. So I'm going to jump over this, the best suited projects, because we're getting towards the end of the project, but you can have a look at that. Lots of prototypes, business management, custom software development. If you need any of this done, obviously, give us a call. So other than that, there's the questions, there's a link to the book. There's an offer in your browser that lets you download the Why Ruby on Rails book, which is different to Confident Software. The Why Ruby on Rails book just goes over why Ruby on Rails is good for this sort of software development project and that sort of thing. But otherwise, that's the end of the presentation. I just had a question come in. So the question is, can I explain what's the benefit of building your own software in Rails and say when something like Salesforce and other subscription platforms can be customized just as well? What's the value proposition of building in PHP or Rails or similar? So that's a really good question. If you can build what you need in something like Salesforce, if you can create the automation that you require in Salesforce, then you should just do it in Salesforce or similar. That's totally fine. When you need to build something in Rails is when you need to build something that fundamentally isn't offered in something like Salesforce. So I'll give you an example. We had a client that was building a application that helped them qualify and gather information from their prospective customers in order to do a certain type of finance deal with them. Now, they could have built a fair chunk of that within Salesforce, for example. They could have asked for forms and leads and that sort of stuff. But what they couldn't do in Salesforce was the complex application logic that determined whether or not this client would qualify or not qualify. And they also needed it to integrate with another back-end system. And they wanted to build a mobile app that hung off the back of that. So that's the point where you start looking at building your own custom software to build out a solution. The other key time that you do this is when the software either is the business or enables the business in a very big way, and you need that software to really portray your brand and your quality and how you want to present to the customer, and you need total control over that. That's where you would go into building a software project. But for example, quite a lot of our clients also use Salesforce, and we do a lot of Salesforce integration. So a lot of the general stuff will be done within Salesforce, and then we'll build a part of the Rails, or we'll build a Rails app which sits external to that, but integrates completely with that Salesforce environment. And this is example what we have as our Store Connect product, where it's an e-commerce solution that's actually a custom Rails application that's built for the customer, but it's 100% integrated back into Salesforce. So you can have the best of both worlds. But the fundamental answer to that question is, if there is a commercial reason that you need to build your own thing because the solutions that are out there just don't do fundamentally what you need, that's when you build it. Otherwise, you don't. Is it cheaper to build custom in open source than something proprietary like Salesforce or SharePoint? Depends on what you're trying to build. If you're just trying to modify an existing process or add a couple of bells and whistles to Salesforce, for example, then it's probably cheaper just to build it in there. If you're building something large and different that needs to be run as a separate application, like a mobile app or something like that, it's going to be cheaper to build it out in open source solutions. The other thing to consider there is that once you build it in Salesforce, it's always going to be in Salesforce. There's no option. You could build, conceivably, an application external to something like Salesforce or SharePoint, which is independent of the backend, and then in the future, you might change CRM. And then you get that application to now point at the new CRM. That could be possible. It would be a lot of work, but it would be less work than rebuilding the whole application. Another question, how long after go live would you warranty your code for if the client decides not to accept a maintenance or support plan? Oh, we have this conversation often with our clients. We actually provide our software development services on a time and expenses basis, and we don't warranty the code as such. Now, the reason we don't warranty the code is because we're building tests all the way through the code project, and the client is constantly accepting that code or feature as done and correct when it's live. So we have basically a big audit trail of the customer going, yes, that works, yes, that works, yes, that works, yes, that works, sometimes 2 times a day, 3 times a day, all the way through to the end of a project. The other way we get around that, though, it's not really getting around it, but the other way that we help the customer get to production without massive bugs is we try and deploy production early. Yeah. So before the project's complete, we need to get production live. And then we make sure we've got a week or 2 after production's live to do any of those final tweaks, bug fixes, all that sort of stuff that are inevitable when it goes live. Now, we have a slightly different business model to some. Like if you're building blogs or a basic e-commerce store and you're selling a product, so you're basically going, look, we have a package, which is a blog that does blah, and instead of you paying for all the development and owning the source code, you're buying our software product and you're paying a 10 grand flat fee, and we're going to implement this. That's a little different because now you're selling a product, and that product would need a warranty of some sort, or it would need some sort of ability for the client to ask for fixes or updates. How long the warranty's for in that case, that's really a commercial decision and what you work out with a customer. But the way that we do that is like with our Store Connect product, for example, there's a base setup fee, there's a custom implementation fee, there's the Salesforce setup fee, but then we charge for a annual license / 24/7 support fee, where if there is actually a bug, like it's an actual warranty issue, we can just fix it. We're getting paid, we can go ahead and fix it. If it's a custom development thing, then we can come back to the customer and say, hey, we need to do some more custom development here. So that can usually fix that problem. If I haven't answered any question fully, feel free to ask again. Okay, another one. What do you do if your client's balance between budget, features, and quality don't match yours? This happens all the time. You just have to really communicate more with the customer. And that needs to happen early in the piece. There's no use trying to go to there is some use. If you're in a situation where you're now at this point with a customer, you just got to figure it out, and you just got to sit down with them and go over everything that's there. But one of the things that you can do, one of the problems, and I actually forgot to mention this, is that clients these days are thoroughly spoiled by the quality of web development on the internet. They're used to picking up things like Uber, Facebook, LinkedIn on their mobile phones, and these applications work flawlessly, and they have every single bell and whistle. And I've actually had clients say to me, the app's not good enough. It's not as good as my Facebook app. And I've actually looked at them and said, well, you haven't spent $15 million this year on software development. So what do you expect? There's like, oh, but it can't be that hard. I'm like, well, actually it is. That's why if it wasn't that hard, LinkedIn and Facebook wouldn't be spending that money. So what do you want us to do? I always try and push, if there is a feature, quality, and budget constraint going on, I would go over, well, we've got to prefer stability over features here. We need to make sure that what we've built works really well. So let's focus on getting that fixed. Get you some money in the door. Get this thing live so it's generating you income in whatever form, goodwill or money or whatever. And then we can justify spending more money on developing more features. That's how I'd approach that. I hope that answered that question. But it's hard. That one is hard. Okay, good. If there are any other questions, more than happy to answer them. Otherwise, we're bang on time. Look at that, 11 o'clock. Even 6 minutes early if you count that I started at 10:08. So thank you very much, everyone, for attending. As I said, this will be up on we got another client in, another question. When talking to a client about maintenance is cheap, how do you approach the conversation of rebuilding the foundations after they've spent on maintenance? Yeah, so the way that the maintenance that we try and do with our clients is incremental upgrades to the underlying foundation as well. So when we deploy an application on Rails, it might be on Rails version 4. Over that year, during the maintenance, we would be encouraging and working with the client to spend some of that maintenance time on upgrading that base version of the application so that we don't need to do major rewrites. But even so, every few years, you would need to go to the client and say, look, it's time we re-architected some of this, or this thing that you were using 5 years ago no longer is really supported, this certain search tool or something like that, so we're going to have to replace that. That just becomes a conversation. But part of that conversation is actually one of the real benefits that you've been spending this money over the years means that we can make this major change much more simply and much more cheaply if we hadn't done that maintenance. And it's going to be a lot more reliable afterwards. So that's how I'd approach that. What is the relationship between Rails and Salesforce? Why do you do both? There is no direct relationship between Rails and Salesforce. The reason we do both is that we do Salesforce integrations and extensions. So Salesforce is effectively a database. Yeah, it's a customer relationship management system, CRM, and it allows you to put in information about your clients. Okay, good. If there are any other questions, feel free to send them through via email, and I will answer them to the best of my ability. Thank you very much for all of you attending. As I said, we will send out the video of this later. Feel free to share it with anyone you need to get them to explain why something is the way it is in your software development. And hopefully all of your projects go better from now on. Have a great day. See you later.